We go beyond the journal articles and into the laboratory and the field as scientists share their discoveries in a way everyone can understand. It's science explained. You're listening to Science Sound Off on Texas A&M Health Talk. Welcome to Science Sound Off. This is Christina Sumners.
And I'm her co-host, Tim Schnettler.
And we're here today with Dr. Pune Badger from the Texas A&M College of Medicine.
Howdy.
Thank you so much for joining us today.
Thanks for having me. This is exciting.
Dr. Badger studies spaceflight medicine. So with the anniversary of the Apollo moon landing, we thought this would be a good time to bring her in and talk about her work. Let's just kind of go back to the beginning. How did you first get interested in this type of research?
So I think when I think about how I became interested in spaceflight medicine, it really goes back to being a kid. So I grew up in a town called LaPorte. It's a suburb of Houston. And I guess what I didn't realize at the time, but I really appreciate now, is that I was about 20 minutes away from Johnson Space Center. So I kind of grew up around this space science environment. And I think a part of that as well is that you realize, hey, when you have a school trip, you get to go see Space Center Houston, you get to go see the Saturn V rocket. You know, these things were kind of built into my childhood. But also part of it is being raised so close to Johnson Space Center, you realize that a lot of people that live in that area, they tend to work for NASA or something affiliated with NASA. And so I have to give a bit of the credit to some of the people that I interacted with as a kid. So first of all, my mom was like really, I think, progressive at the time. She said to me, you know, if you're good at math, you'll be able to get a job. So she really said to me, you know, I want you to be able to study math, learn math. Well, we had a family friend that worked at NASA, and he actually still works for NASA. And he is an engineer by training. And so he would tutor me in math. So he taught me algebra, he taught me geometry, he taught me all this stuff. And it really set me on a path to study math. Not biology at all. I actually really got interested in kind of these STEM fields through the math side of things. But what I thought is interesting is when I was a kid, because we knew someone that worked at NASA, instead of getting, I don't know, stickers of cartoon characters or bands, I would get stickers of the mission patches for various shuttle missions. And as a kid, we had this desk, and we would stick all these stickers on them. And I to this day, the desk is still there. So my mom kept it. And about 2 or 3 months ago, I went back, and I took pictures of every single one of the stickers and figured out what the mission was that was associated with it. And what I think is really cool is one of the stickers was STS-40, which was the first mission where they had the Space Lab module that was dedicated solely to biology research. So it's cool to me that as a kid, I walked past and saw this sticker probably my whole life and never realized that one day I would be involved with biology research related to space. So I think that really how I became interested in space was maybe constantly having it there in the background and being a kid growing up in Houston saying, wow, NASA's so cool. I hope one day I can do something with that. And that was always in the back of my head. So as I became a research scientist and my lab studies how blood vessels function, I always thought to myself, how can I relate this to NASA? Actually, Texas A&M has a really strong link with NASA research. And for me, I thought, hey, I'm here now. This is a perfect opportunity to get involved. And so I just interacted with people in the local community and figured out, hey, how can I help answer questions that are related to spaceflight medicine? But I think it's just so cool to go from having this mission patch that I saw as a kid and convert it into a mission patch for a mission that I was involved in. So it's really exciting.
You were always interested in space as a kid, so how did you get involved in the medical aspect of it? How did that come into play, and what got you interested in that side of it?
Yeah, so I think it's interesting when I look at the kind of people that I've interacted with that work on spaceflight medicine, they kind of come from two sides. So either they're always interested in space and they focus on space and then they kind of focus on a problem, or someone like me who has spent probably a decade plus studying how blood vessels function and then realize that that's an important area for NASA, and then turn my focus into how I can use this information, how can I use my knowledge to then answer a question for them. So I'm kind of that second avenue. And so really it was just a matter of saying I can fill a niche, or I can answer a question that may otherwise, it might be difficult to answer or something like that. So yeah, I think it's mainly just being able to utilize my background to answer a question.
So why is NASA interested in blood vessels?
So NASA's been interested in how the spaceflight environment affects a number of biological systems. And one of the first kind of characteristics that they observed when astronauts returned to Earth was orthostatic intolerance. So essentially, when an astronaut returned, they were unable to walk without fainting or to stand up without fainting, essentially because of how the blood flow was redistributed once they came back to Earth. So that kind of flagged the interest in the cardiovascular system from the get-go. But we know that blood vessels, these are the blood vessels that transport blood throughout your body, they're really important for how blood flow is distributed. And so essentially by studying the blood vessels, you can kind of get a glimpse into how some of these cardiovascular changes are occurring.
No, I didn't know they fainted when they would come back. That's
Yeah,
interesting.
That's crazy.
And actually, so that's why exercise is a really good countermeasure.
Oh,
So this
okay.
is important because essentially they observe this and they recognize that this actually becomes worse with longer duration missions. And one of the countermeasures, that's what they call pretty much what they do to try to counteract these effects. The countermeasure of exercise helps reduce that. So that's why actually astronauts exercise for 2 hours a day, 6 days a week on orbit. Yeah.
Wow.
So it's a countermeasure. But and there are a lot of studies now that have been able to identify changes specifically in how blood vessels function during and post-flight. And so the thing is there's blood vessels all over your body. So there are many different types of blood vessels that you can study. So I thought maybe it might be interesting to talk about that. When we talk about the cardiovascular system, I think people are pretty aware of the heart, how important it is for distributing blood throughout the body. And maybe what we don't appreciate as much is that there have to be both global and local mechanisms that say, hey, I need blood flow to this area. So as we're sitting here talking, we probably don't need blood flow running to all the muscles in our body, like we would be if we're in a sprint. So let's say a bear comes at us. This is a really good example. So if a bear comes at us, there's this fight or flight response, and actually blood is redistributed from your gut to your muscles. Certain areas like your brain stay pretty level throughout this process, which is important, right? You need your brain to function whether we're sitting here talking or when you're running from a bear. But when you're running from a bear, you need the blood flow to your muscles to increase, but maybe not to your gut. So we have a lot of these mechanisms whereby we can say, hey, we want blood flow to go here, but not here. And so that's kind of another element of this is if you think about how blood flow regulation occurs on orbit versus how it happens on Earth, there might be changes because here on Earth, if we're standing, we actually have blood pulling to our lower extremities. So
Sure,
gravitational
gravity.
pull,
Yeah.
right? And then you have a number of mechanisms that have developed that say, hey, we need this blood flow to go back. So we have pumps, we have skeletal muscle pumps, we have ways to redistribute our blood flow. But once you go on orbit, those things go away. So actually a lot of the fluids that pull in our lower limbs actually go up to the torso and up into the neck and head region. And that's why sometimes you can see an astronaut might have a puffy face on orbit versus on Earth.
Okay.
And so there's this redistribution of fluid.
And that would be why when they try to stand up when they get back on Earth, their legs don't have the blood flow, right?
It's more that their brain doesn't have the
Okay.
blood flow because
Okay.
it goes back down,
Goes back down.
and the mechanisms that control that actually start to shift and change when they're on orbit.
It's amazing.
Yeah, it's pretty cool
It is.
stuff.
That's amazing stuff.
Yeah. And the longer they're up there, the more these changes happen? Is that?
Yeah, so some of the shorter duration flights, they would observe some of these changes, but then when you would have longer duration flights, some of these things would be exacerbated. And when you think about the spaceflight environment, we think about, astronauts floating. So this idea of microgravity That's kind of obvious. But also there are other elements that you have to think about. One is that they have increased exposure to space radiation. So actually in low Earth orbit, where the International Space Station is, they're still protected from quite a bit of the like kind of deep space radiation. However, their exposure would be higher than us here on Earth. And then there's kind of other elements which deal with like behavioral and kind of the stress of the space flight environment in general.
Being away from friends and family and
Isolated
isolation.
space.
Yeah.
Yeah, so those are some of the concerns in particular for the longer duration flights back to the moon and Mars. So once you get out of this magnetosphere, which is not really a word I made up, it's real. But yeah, once you get past the magnetosphere, then you start to have exposure to kind of these higher ionizing radiation, and that those can potentially be more damaging. So there's a lot of interest not just in how microgravity affects various systems, how stress and isolation and things like that do as well, but also the space radiation exposure. So you really have a couple of different elements that people are interested in. There are ways to study kind of galactic cosmic rays, space radiation on Earth. There's a few places that you can actually irradiate samples and see how it affects various systems. But really, sometimes the only way to get all of those different components together is to actually do experiments on the International Space Station.
Just because it's hard to get the microgravity on Earth and the radiation. Yeah.
Yeah, there's ground-based kind of assays that people use.
Okay.
But just like everything, there's always kind of the pluses and minuses to all these different assays that you can use. So spaceflight really gets all of the components as similar to the International Space Station environment as possible.
You mentioned space radiation. How is that different from just radiation we encounter here on Earth?
So one thing we know about kind of deep space radiation when you exit this magnetosphere is that there are a lot of these high energy ionizing particles. And these are known to be more damaging to cells. And so a lot of researchers have looked at how this could be related to cancer risks, for instance, and recently interested in how that might affect the cardiovascular system, in particular how blood vessels function. So it was one of my colleagues that have done some of these studies. So really space radiation is different in that it's the type of radiation that you have, first of all, but also the type of exposure that you would have. So once again, this idea of total body irradiation that an astronaut would potentially be experiencing, where it's not just a focal delivery. And so that's one of the main differences from what you would have here if you're experiencing, for instance, radiation exposure for a medical purpose. A lot of the physiological responses we have here on Earth would be different on orbit because of the microgravity, because of potentially space radiation and some of these other factors that can affect the astronauts.
And this will be especially important as NASA plans for longer term missions to Mars, for example.
Right. And
Okay.
back to the moon.
How did you get paired up with NASA? How did you, I mean, obviously there was a grant proposal or something like that you had to go through, but what made you decide? You mentioned that your background, as a kid, you were a NASA freak.
Yeah.
Basically, pretty much a NASA freak.
Sure, NASA geek, whatever.
Is that what drove you to go with this aspect and try and combine your research with them?
Yeah, to be honest, like, how often can you say you do work for NASA or you do research for NASA? It's just the coolest thing. And I have to admit that it motivates people in the lab. What I like about doing NASA research is it's exciting.
Mm-hmm.
And people, I have a story about how NASA got me interested in math and science. Really,
Right.
I wouldn't be here if it weren't for NASA. But at the same time, I think everyone has that story. Unfortunately, I wasn't around to see the moon landing, but so many people can remember that moment
Right.
where they were sitting in front of a television watching the moon landing, and that affected them. And there are people who have become engineers and scientists and mathematicians, because of that experience. And I think that that's one of the things that got me interested in it from an overall perspective. When I think about how it really works out is that there were people at A&M that were doing research for NASA. And when I found that out, I said, I need to talk to them. Like, and pretty much what I said is, how can I help you?
Right.
How can I use my skill set to help you answer the questions that you need to answer? And that's how I got linked up with it. And I think that maybe that's a lesson that if there's something you're really interested in, reach out to the people who are experts in it or who have experience in that field, because you never know when your skill set can help answer a question that it couldn't be answered before. So I think that's really cool.
And it's easy to see the passion you have for it. I mean, it really is. I mean, just listening to you talk and the way the listeners can't see your face, but the excitement on your face. I mean, it's obviously something you're very passionate about.
Yeah, I love it. I feel like sometimes I wake up and I feel lucky that this is what I get to do for a living. Like, I get to sit here and talk to you guys about space. Like, I never thought that would be the case.
When you were doing those math problems, you never thought that you'd be sitting with us two, right? The two of us.
Exactly. I can tell you that my math tutor, so the engineer from NASA used to make me write negative signs always get me, because I used to always mess up the negative signs in my equation. So, when I was writing this down many years ago saying, okay, pay attention to this, I never realized that it would all come full circle. But
see, you hear that, kids? Do your math.
Yeah, do your math. And I think I turned my interest in math into an interest in biology, because there's actually quite a lot of mathematical principles in physiology. And so it was a natural link for me to go from one to the other. But, I think it's just such a great time to be interested in space as well. I was thinking about this just this morning that, when I was a kid, I had these stickers, but it wasn't easy for me to Google what STS-40 was.
Right.
You had to kind of know. Whereas now, there's NASA TV where you can watch the rocket launches. You could have watched shuttle launches, and you can watch SpaceX launches. You can watch Blue Origin. You can watch all these other things. You can watch them. And so you could be anywhere in the country or world and really still be able to experience space. And I think that is so such a unique experience that people can have now. I mean, I set my alarm to try to wake up for the Falcon Heavy launch the other day. And I remember I was in my office doing some work, and I knew the first Falcon Heavy launch was happening. And I stopped what I was doing and I watched it. And I remember just being so excited to watch that. And I think other people have that experience as well. So everyone has that link with NASA. How about you? Any NASA experiences?
When I was a kid, I did have models of the space shuttle and stuff like that. I had an uncle we called him an uncle. He was a friend of the family, but he worked at NASA, and so I got to go to NASA as a kid as well. But I wasn't into math, so I never got that. So that's why I'm over here and you're over there. But I did. I remember the experience, and I remember waking up to watch the shuttle launches and watch things like that, because they would, it would be televised in some aspect. And I do remember watching that stuff.
You can find these things that have been, recorded, so you can experience them again.
Yeah.
So I actually had the opportunity to go to Kennedy Space Center to watch one of the Falcon 9 launches, and it was the one that actually our experiments were involved in. And it was such an amazing experience. So first of all, I don't think anyone tells you this or warns you about this, but it's so loud, and you can feel the room shaking. And it was funny because at the end there were some tiles, like I had to dust my shoulder off. There's like a little bit of dust from the tiles above me. But when the Falcon 9 rocket took off, we could see the plume of smoke, but essentially it was really, really bright, and I had to kind of look away for a second. So it went up, it was like fireworks, it was really loud, that's what it felt like. But this was one of the times that the stage one came back and landed. And this is the other thing no one warned me about, so I'm warning everyone out there. So there's essentially a large sonic boom when it lands. And so it's just this incredibly loud boom, and no one warned me of it. So of course I screamed and I freaked out a little, but it was so amazing to watch and to know that, I was involved with a project that was
on its way to space.
Yeah. And there were so many people that are involved in getting, the cargo up there. And once they get up there, there's just the astronauts and the time that is required. But being able to watch one of these live was probably one of the coolest experiences that I've had. And I want, hopefully one day, to go out and see one of the Falcon Heavies, and it's just such an exciting time, really.
How do you see the results of the experiments you've been doing of helping astronauts, especially on some of these longer space flights? What have you learned that might be applicable to them?
Essentially, some of our data shows that blood vessels respond slightly differently to various stimuli. And what I think it draws to light is that how things respond in space is going to be different than how they respond on Earth, firstly. And then secondly, if you, for instance, need to take a medicine that might affect how a blood vessel dilates or a blood vessel constricts, then it might be slightly different in space than it would be on Earth. So how much of the medicine you would need to take or what type of medicine you might need to take. So I don't know if we want to go into that detail, but I think in general the idea is that it's definite. There's evidence from our group and there's evidence from other groups that how blood vessels respond to stimuli that are just routine here on Earth are slightly different on orbit. And whether that's some sort of compensatory mechanism, that's kind of to be further elucidated. So what have we found that might be informative for long duration missions is that we have observed differences in how blood vessels function post spaceflight than they would do here on Earth. And I think it suggests that there are adaptations that are occurring and that these adaptations will likely occur for longer duration missions. And then when you added components like space radiation, some of the stressors of spaceflight, then you might have some additional changes that would occur on top. So really, our data gives us a nice snapshot of what happens in low Earth orbit, and then we can start adding these other elements to it and get an idea of if things change in one direction or another. I guess one thing that I'd like to say is, I really only started doing research for NASA about 2 years ago. And so I'm still learning, and I'm realizing there's so much to learn about the spaceflight environment. And I think what it shows me is that, yeah, maybe you're obsessed with NASA or space since you're a kid, or maybe you just got interested in it 2 years ago. It really doesn't matter. It's an accepting, welcoming area, and you can find your way. And so for me, I feel like even though I'm new to it and I'm still learning, and there might be things I don't know, it's okay, because there are things that maybe we don't know in general, and that we can answer together through kind of our curiosity about how things work.
Well, we'll look forward to having you back on as you learn more and work more with NASA. That's so exciting.
Thanks for having me. This is so exciting.
Thanks for being on. It was a lot of fun.
It was. And if you want to learn more, we can put some links to Dr. Badger's research in the show notes, so you can go read more about what she does. And thank you so much for listening. This has been another episode of Science Sound Off, and we'll see you next time.
Thank you for joining us on Texas A&M Health Talk, a production of the Texas A&M University Health Science Center. Visit us on the web at vitalrecord.tamhsc.edu, where you'll find answers to all of your health questions. Until next time, stay healthy.